once again. Uh, it's been a while. So today I want to showcase my second designed bicopter. This is designed by me, and this is actually the second one. And the first one flew it, and I love the performance. And I'm hoping to achieve the a greater stability or much more better stability on this one, and also fine tune it beyond the way I did the first one. So um, this biocopter I make use of this brushless motor 2204 2300 kV motors, 20 amp ESC, rating 2 cell to 4 cell, which is 7.4 volt or 8 volts to 12 volt. Okay, so looking at my screen, you see I have you see the first design. This is the first design. This is what the first design looks like. I'm going to actually post the flight video of this first design, and also this is the second design, which I've already printed again, and here is with me. And I have the cover here. The GPS is going to be sitting here. So okay, so this is what it looks like, and I've installed the motors, and want to secure the brushless motor properly. Okay. So, okay. Then the next thing is to install the uh, servo, which is the for the tilting mechanism. Okay, so I have this here, and here I'm using the 9 gram. That's a MG90X servo, which is 9 gram servo, to be able to tilt this the two motors front and back. So how does this work? So this biocopter work by when the motor is spinning, the higher the RPM, which is the higher the speed of the motor, it makes it to generate lift up. And why it generates lift up, then it's going to detect the RPM at which it can hover on its own, that it can take the weight and hover on its own, and try to keep the motor spinning at that RPM for it to hover on its own. And here, this is actually different from the conventional quadcopter. This is only using two motors. So tilting these two motors forward, it will make the biocopter, or it will make the copter fly forward. And tilting the two motor backward is going to make the biocopter fly backward. Okay, for it to turn left and right, for it to turn left and right, when this motor, which is the left motor, reduce speed and this right motor increase speed, the copter is going to tilt to the left direction and fly to the left direction. And when this reduce speed and the left motor increase speed or increase its RPM, is going to fly tilt to the or bank to the right direction and fly to the right direction. So for your one will tilt backward and another one will tilt forward for it to yaw. So that's how this biocopter works. So then now I'm going to install the servo for the tilt mechanism. So here, think first thing first. So I'm actually using the same electronics, the same setup that I've used for the first one. Please like and share this video. I've flown the first one and it's working. It flew nicely and perfectly. So I hope I have copied the video on this screen. I will have projected here, but I'm still going to post the video later on. The design is different from this one, so let me keep moving by installing the servo. Okay, so now this the servo for the right arm. Now it's in. Now it's in. Then I'm going to pass the servo wire for it to get into the fuselage. Okay, so it's in. So we're going to connect all these to our flight controller for it to be able to control the drone. So now you see, when I tilt this, you see it's moving the motor and the propeller, which is going to cause it to create that stability for the drone. So now I have the second servo here, and don't forget I said this is different from the normal quadcopter. Instead of making use of 4 motors and propeller, we are making use of just 2 motors and propeller, then compensate it with the servo for tilting, for stabilization actually. Okay, so please do well to like this video and give it a share. Thank you. So now installing the second servo for the left arms. So now it's in. For the left arm, now it's in. Okay, you can see. So now again I have to pass the wire in so that it can be connected to the flight controller, because it's our flight controller that is going to be doing the control for our stability, or for the stability of the drone. Yeah, so it's in. Now it's in. Please give the video a thumbs up as you're watching. So now first I'm going to secure it with a zip tie. I'm going to secure it with a zip tie. So the left arm is secure with a zip tie. You can drop your comments if you have any question. I will attend to your question. If you have any question, you can drop it on the comment section. I'm going to attend to it. So okay, so also this, the ESC, so I have to secure it with zip tie also. So the third design is going to be uh, much more beautiful. Like I'm going to put into consideration the ESC setting, or the ESC spacing, so that it's going to pass through uh, inside the arm of the drone. So now I have to secure the second arms also. Securing the second arms also. The reason why I like this, the reason why I actually built this biocopter is because it's challenging. It's challenging, and I love challenge. So getting two motors and two propeller to put a drone on air is actually challenging compared to using 3 and 4, which everything just work by reducing and increasing speed. Yeah, so okay, so now it has been secured. So the next thing is uh, okay, okay, so the next thing is, please do well to like this video. I've not seen any likes yet. Do well to give it a thumbs up, please. So the next thing is the installation of the flight controller. So here I'm using the Martech flight controller, which is a Martech F405 width. So this is the same setup that I used for the first one that I've flown, and I'm transferring the setup to the second one. Okay, so here, although I'm going to do a little conversion, I'm going to change the um, the power in plug. I'm going to change it. This I use the ST60 connector here, and also use ST30 connector to split power for the both ESC. So now I'm going to split I'm going to unsolder these, and have to solder the ESC directly to the flight controller to actually make the work more neater. Alright, for those who have been following, thanks for watching. Yeah, so let me just do a okay.